Hey everyone, on this side, I hope you all are doing well. So let's see the problem of the day. So the problem here saying is earliest finish time for land and water rides. Okay, so we are given an four array consisting of land start time, land duration time, water start time, and water duration time. Okay, so land start time means the earliest time to start the ith ride can be boarded. I mean, basically, we are given one is for water, another is for land. Okay, so for example, we are given here 1, 2, 3, 4, 5, 6, and this is the land start, and this is land duration, and then there's 7, 8, 9. This is water start, and this is water duration. Okay, 6, 4, 2. So basically, what it's saying that in for every ith index on the pair, I mean, let's if consider land. So what it's saying that it gonna start at I second, I mean 1 second, and gonna, I mean 1 second, and gonna run till 4 second. Okay, the duration to complete the ride it's 4 second. You can consider any unit, and here we are considering seconds. You can consider minute, hour. So and here the this ride was starting at 3 seconds, and after 3 seconds, and it takes 6 seconds to finish the ride. So, okay, so basically here the timeline 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so let's consider this ride. So this is starting at 2. Basically, this is starting at 2, and after starting, it takes 5 minutes to finish. Okay, so for example, this ride starts at 2. Okay, so you can go to this ride at any second after 2. Okay, and this took 5 seconds to finish. Okay, so let's consider we started ride from here. So it took 5 seconds. 1, 2, 3, 4, and 5. Okay, so it took 5 seconds to, so till 8. When we gonna finish this ride? For in 8 seconds. If it started from 2, but we boarded the ride at third second, and it gonna finish in 8 seconds after 5 seconds. Okay, so if I write, and what basically the says is tourist must experience only one ride of each category. I mean, a tourist which is gonna experience one water ride and one, I mean, any one pair of land ride and any one pair of water ride. And after, I mean, after finishing the land ride or water ride, they can immediately switch to another ride, and we have to return the minimum time. I mean, we have to return the earliest possible time at which tourist can finish the boat ride. Okay, so let's see if we consider this. So for now, we are considering a, I mean, for now, you are having a timeline. So let's start with 0. I mean, so first go to the, I mean, land ride. Okay, so what we are going to do first, we gonna board the land ride. So land ride gonna start at 5, 0, 1, 2, 3, 4, 5. Okay, so land ride gonna start from here, and it lasts till 3 seconds. So 1, 2, 3, 6, 7, 8. So this is the time taken by ride. And after this, the water start time is at 1. Water ride gonna start at 1, and after land finishing land ride, we can go to water ride. So we are going to go water ride from here, and it's gonna take 10 seconds. So 9 till 18. So we started from 8, and we're gonna finish at 18. So it was the land ride of 3 seconds, land ride of 3 seconds, and this was the water ride of how many seconds? It took 10 seconds. So the finish time here is 18. So we finished at 18 seconds. So what if we take and the alternative approach, first go to water ride, then go to land ride. So let's withdraw the timeline, and starting from 0th index. from, I mean, 0th second, first second. So water ride gonna start at first second. So we quickly gonna join the water ride and gonna finish it at 11th second. So after joining the water ride, we gonna finish it at 11 second. It total took 10 seconds. So after finishing the water rides, I mean the land gonna starts at 5. So somewhere here it's 5. So land ride gonna start from here. So after finishing the water ride, we're gonna step onto the land ride. And after stepping on land ride, what we're gonna do? We're gonna stop after 3 seconds. So it's gonna take 3 seconds. So 11 after 3, it's gonna stop at 14 seconds. So here we finished at 14 seconds. So if we took the water ride first, we're gonna finish at 14 seconds. If we took the land ride first, we're gonna finish at 18 seconds. And there are multiple pairs of doing so. So for here, let's take this example and see. That was the first second, that was the second, that was the third. So what we're gonna do, we're gonna pick the, for first case, we're gonna pick the zero land, zeroth index of land ride and zeroth index of water ride. Okay, so for first, we're gonna pick this. Let me write it somewhere else. Okay, so we are going to take for zeroth index of land ride and zeroth index of water ride. So zeroth index gonna start at 2 and the duration of that ride is 4 seconds. So it gonna start at 2 and duration of that ride is 4. That is 3, 4, 5 and 6. So it gonna finish at 6. Like it started from 2 and finished at 6. That was the land ride of 4 seconds. And the wait a second, the water was going to start at 6. The start time is 6, so it gonna start at 6. And after finishing the land ride, we can immediately switch to water. So the duration of water ride is 3 seconds. So the 3 seconds are gonna look like 6, 7, 8, and 9. So the water ride gonna last till 3 seconds. So here are 3 seconds. So what will be finish time? Here finish time is 19. I mean 9 seconds. We finished at 9 seconds. So on taking this combo, we finished at 9 seconds. Let's take another combo. The second combo gonna become. um, let's reverse this. Zeroth index of water and zeroth index of land. So first we're gonna take the water at 10, and then we're gonna take the land ride. So here is the timeline, and the first we're gonna take the water ride. So water ride gonna start at 6 seconds. So after 6, we are going to take a water ride of 3 seconds. So taking a water ride of 3 seconds. 3 seconds. So after taking the water ride of 3 seconds, we're gonna move to 9th second. And after 9th second, the land ride gonna starts at second and second seconds. So we so after starting and then finishing the water ride, we're gonna move to land ride of 4 seconds. And after finishing 4 seconds, 9 plus 4, that gonna be 13. We're gonna finish it at 13. So here total time is 13 seconds. And now move to the third arrangement, that is, I mean, first index of land and second in zeroth index of water. So first index of land and zeroth index of water. So here is the timeline. So first index of land gonna start at 8, I mean 8 second and gonna last till 1 second. Okay. So first gonna start at 8 second and gonna last at, I mean duration is 1 second. So it gonna finish at 9th second. So this is the land of 1 second, land ride of 1 second. Then after finishing, the water ride gonna start at 6th second and finished after 3 seconds. So somewhere here 6. Water ride gonna start from 6th, and after finishing the land ride, we're gonna switch to water, and it gonna last till 3 seconds. So 9 plus 3, that gonna become 12. So the ride gonna finish at 12 seconds. So total time taken here is 12 seconds. And the next combination gonna be fourth combination, that is zeroth index of water and first index of land. So zeroth index of water started at 6th second. So first start at 6th second, and after 3 seconds, 7, 8, 9, it gonna finish. So here is the water ride of 3 seconds, and the land ride gonna start at 8th second and gonna last till 1 second. Start it at and gonna last till 1 second. So the land ride will start at 8, and after finishing the water ride, we're gonna move to land ride. And after finishing the land ride of 1 second, we are standing at 10th second. So it took total 10 seconds to finish. So the shortest we got is 9 seconds here. So we have to return the 9, the shortest time to finish the both rides in our in arrangement of our charge. We're gonna take 9 seconds. So how we gonna code this? So first of all, you see, so we have to select the shortest ride. Okay, so first select the index, and then select the type of ride. Okay, so what are the type of ride? It gonna be water and land. So okay, so what, so suppose we are selecting the x index of land type, and then y index of water type. Okay, so we have to select the minimum, we have to get the minimum time to finish this. So the first combination is go to, first go to land and then water, and the second combination gonna be first go to water, I mean something a water, then beat index of land ride. Okay, like that. So how we are going this index, minimum. So what we are doing is, I think, let's take the open one when the first ride open, and duration one, the duration of first ride, and open to when the second ride's open, and duration to when the second ride, the duration of second ride. Okay, so how we gonna do is first go to, first go to the first ride. Okay, so the first ride gonna become like, so we have to check the every combination for the open, for the first ride. So for int I equal to 0, I less than open one dot size plus, so that we are basically, open one represents the time where the rides open, the first ride gonna open, and first ride gonna become anything for, let's consider here first ride is land. First, let's consider first ride is water. So open gonna contain the elements where first ride, the water rides open, and duration gonna contain corresponding elements when the duration is, when that duration taken to finish that ride. Okay, so when we're gonna start the first ride, exactly when it opens. So starting first ride equal to open of that ride, and when it gonna finish, finishing first ride equal to start of first ride plus duration taken to finish duration of first ride of that ith index. And how we gonna find the minimum? We just gonna minimum finish equal to minimum of finish one, comma, finish one and minimum finish. Let's consider the first minimum finish, and first minimum finish equal to enter max. Okay, so here we got the first minimum finish when the first thread gets finished. So after finishing the first thread, we're gonna move to second thread. So for open to dot size. So when we're gonna start the second thread is gonna start at start to equal to maximum of finish one, min finish one, and min finish one, and the open of second thread. Okay, so we're gonna start the second index at the and why I write here max is because if we see here when we are starting the second thread, I mean let's consider here water. So when we are starting the water thread, it's either the I mean the start time of water is 6 and the finish time of first ride is 9, but we are starting at maximum, that is 9. So after finishing, we can start, or either if if we, I mean, the ride is gonna start up late after finish, so we're gonna start at there. Okay, so we are gonna the after time. We can't, I mean, go in back in time. Like if we saw here, so consider you finished a ride here. Okay, and another ride is started here. So started here. So when you're gonna start the ride second after finishing this ride. Okay, so this is the maximum of these two values, finish one and start one. So this is min finish one and this is open one. So we're gonna the open one and min finish one. So we're gonna start at the min finish one. In the another case here is if we finished a ride one and second ride is starting late after the finish of ride one. Okay, so this again pick the maximum. So we're gonna start after starting this. So it after opening the ride two. So we're gonna pick the ride two. So that's why I wrote here maximum. So we're gonna start when which was available at the time. We can't go back in time. Okay, so after starting the finish two is start two plus duration 2 of that, and min finish 2 equal to uh, minimum of finish 2 comma min finish 2, and after completing this, so we're going to simply return the min finish 2. Okay, so we're going to return the min finish 2. I mean these are the four parameters our function was taking, and this is the first finish line. We have to also write the second finish line, I mean second finish point, that is okay. So this is the second finish line and second finish point. We the first starting is exactly when that ride open. The second in starting is either, I mean if if we started early, we're gonna start at a maximum with, I mean, after finishing the first one. And if we started later, we are going to start, we're gonna choose maximum this one. I mean, that is when it started after finishing. Okay, so this is finish two, and we're gonna return finish two. I mean, after returning finish two, we are so let's call this function. These were four parameters. This is function. We'll call this function solve. So what we're gonna do is called for, so the first combination we can take here is water land, first water then land, and for first water then land, the minimum we are getting is by calling solve, and for first water we're gonna insert water start, water duration, land start, and land duration. Okay, and for land and water. We're gonna solve land start, land duration, and then water start, and then water duration. Okay. So after solving this, we're gonna return minimum of water land and land water. So that's the whole code. So let's try to code it. I mean, let's try to code it and see. So first create the solve function. Get take parameter as after this what gonna happen is the main finish word, minimum time to finish the first thread equal to int max, and the minimum time to finish the second thread is also int max, and then go and then visit every index of first thread, that is int I equal to 0, I less than open one dot size, then I plus plus. So what we're gonna do here is when we're gonna start the first thread, exactly when it opens, open when we're gonna finish this first thread, just after starting, and the duration taken by first thread at that I index, and the minimum finish time of first index in first thread is gonna become minimum of finish of first index comma finish, and for second thread I equal to 0, I less than open 2 dot size, and I plus plus. When we gonna start this gonna become max of finish one and min finish one, and min finish this gonna become the start of min finish one and open of second thread, and with when it gonna finish at after starting the duration taken by the ride, and minimum finish time of second thread gonna become minimum of min finish to of finish, and we simply have to return the min finish to. And basically now here we have to call in water to land equal to, we have to call the solve function, and first we have to go to water, so we're gonna pass water start time, then gonna pass water duration, then gonna pass land start time, then gonna pass land duration, and for land to water we gonna solve it by passing first land start time, then land duration, then water start time, then water duration, and we're gonna return minimum of water to land and land to water. Let's run the code and see we got any error or not. So the code ran it once. So let's submit the code and see if it's working or not. Okay, we got a perfectly fine code. So if you analyze the time complexity here, this solve, the solve function gonna take big of m plus n time. The size of the size of the number of land rights plus the number of water rights. So this solve gonna takes big of n plus m, and we are going to call it twice. So it gonna takes big of 2 times 2n plus 2n. That's gonna become time complexity equal to n plus m, and the space complexity here we are using is. I hope you liked today's video, so please make sure to subscribe to Tensor and feel free to ask any doubts in comment. Till then, keep smiling, keep coding.